Namaskar, welcome back. So, in previous lectures, we have discussed about the seismic waves and the effect of the seismic waves and all that. Now, slowly we will move to the field techniques. But before we go to the field techniques and understand about the landforms, plus your what we see in the sediment successions, that is the exposed stratigraphy, to understand the deformation and to identify the deformation and differentiate the deformation pattern from non-deformation patterns. So, that what we call primary and secondary structures. So, primary structures are basically the depositional structures in sedimentary environment, and we have the secondary uh, structures or features which are developed later on because of the ongoing deformation. So, in this we will have the basic understanding, we should have the basic understanding of the structural geology. Okay. So, usually we see that the structural geology defines and makes us understand about the forces and the stresses of acting upon on a particular area. Uh, and that results into the different deformation, and at the greater depth we will have will see usually the uniform deformation, but closer to the surface if we see, then we have the differential deformation, and mainly the plate boundaries where we see the deformation, and where which for where in which the areas in which we will be interested will be having mostly the differential deformation. So, if you have the uniform deformation, then any material will deform uniformly. But if you are having the differential stress, okay, where we see a sort of an take into consideration sigma 1, sigma 2, sigma 3, then we will have a differential deformation. And mostly this is what we see is that sigma 1 max, intermediate and minimum, okay, that will result into your differential deformation. And when we will be talking about the different type of faultings, there also we will have this discussion on the sigma 1, sigma 2, sigma 3, where sigma 1 plays, that is the maximum, plays an important role in providing different type of deformation. Now, rocks or sediments usually occur in form of layers covering large area, and these layers, mostly if you take the thumb rule, then they will be deposited horizontally. But if you are having the inclined topography, then you will see an inclination, okay. But that doesn't mean that it is resulted because of the deformation. But in areas where we have the understanding that these are the plate boundaries and there is an ongoing deformation in this region, then these layers, under influence of tectonic forces, will exhibit complex structures, where you see bending in the layers, warping or folding, fracturing, displacement along a definite plane, and that what we term this as an structural features. Okay, and the engineers basically call this as an discontinuities. Okay, so fundamental structures, we can classify this as an primary structures, secondary structures, and contact structures. Okay. Now, primary structures basically, as I told, that they are all depositional structures and deposited, or even if you are having the volcanic rocks and all that, they will be deposited or layer by layer. Okay, and secondary structures are your deformation, and contact structures are where we see in a geological process the intrusions where we are having. Okay, those will result into your contact structures. So, to have this basic understanding, we have prepared this lecture where whenever we go in the field and try to identify or decipher the tectonic deformation, then we should have this thing in our mind. Okay. Now, coming to the primary structures are those structures which are developed during the phase of formation of a rock or during the phase of deposition of the sediments. Okay. And this structures, the primary structures, usually if you will come across, because we will be dealing with the young deposits, and that is also within the range of the Holocene for this particular topic, then we will come across the sedimentary structures also. And they can be small scale, they can be large scale also. So on the right hand side, the photograph which you see is showing your typical sedimentary structures, okay, where you are having the top sets, you are having the bottom set and the foresets. Okay. So typical cross stratification. So, and in sedimentary rocks, you will come across beddings. Okay. And for example, in metamorphic rocks, you will see the bends. Okay. In gneissic rocks, if you look around, then you will be coming across the bends, and those are not related to your ongoing deformation. Of course, when we talk about the metamorphic rocks, then we say that, okay, fine, these rocks have gone under the high temperature and pressure, and that has resulted. But this, even the gneissic bends or the foliations which we see are not exactly the pattern which you will come across in the terms of the deformation. Okay. And also, we in some areas where you see mud cracks, okay, so cracks which are formed are nothing to do with the ongoing deformation. So one has to be very careful when observing this feature and basically differentiating between tectonic and non-tectonic features. Now this is a very good example from Kutch region, a few kilometers north of Bhuj, where we came across a huge trough. Okay, and that is your, if you can see the person which is standing here, so this trough, okay, which shows the contact over here, this is the contact of the trough. This is nothing but this is a paleo channel, and this is what we call trough. Okay, and this is what your contact is, your bonding surface. Now this part, basically what process it might have gone through in this area was that this channel eroded, okay, the earlier. So this is an older sequence and this is the younger one. So this eroded this older sequence, and what we see an erosional contact. So bonding surface here is erosional in nature. So original erosional surface. Now there is no deformation here. Okay. But if you in isolation, if you study, for example, this portion only, okay, then this portion will show, or you will be able to gather, is that there is a contact here, okay, where you are having the older sequence here, and this is the younger sequence. Okay. Now this can be interpreted or mistaken as a fault. Okay. For example, if you put in sort of a block diagram here, then how you will be able to see this. Okay. For example, you have an all horizontal deposited sediments, as we were talking about, that as a thumb rule, and then there is some faulting which has happened, which has resulted into the displacement. Okay. So what you are looking at is this contact, okay, the contact along this plane, and that will give you a sort of an mimic or false interpretations you may may make, okay, looking at this contact. So in most of the time, what has been advised is to see regional contacts and the regional structure. Okay, that allows you to have a proper and correct interpretation. People have done this, and wrongly interpreted such features as fault contact. Okay. Then when we are doing the trenching and trying to expose the fault plane as well as the deformation sequence. So we usually, if there is an, like for example, if you look at, like, there is a deformation and there is a fault scarp, which has developed over the time because of the displacement on fault. Okay. So usually what we do is we open up a trench here and then we try to see the displacement in that. Okay. So this is on the fault trace on the surface and this is in section. Okay. So at that point of time, when you have exposed the sections, you need to have a proper understanding of sedimentary and like tectonic features. Okay. So you need to differentiate between the unconformities which are resulted because of the deposition or erosion and the tectonic unconformities because of the displacement. Okay. So if you look at this one, these are the areas of the trench which we saw, and clearly we see a sort of the primary structures are inclined. Okay, here. So if you very carefully look at and trace this, then you see a sort of an inclination over here of this layers, sedimentary layers, and they are abutting somewhere over here. So this contact is purely your tectonic contact. Okay. And again, the inclination here is related to folding. This inclination is related to folding because when you come towards the this is south here and this one is north. So if you come towards the north, then you see that this layers are slowly becoming almost horizontal. Okay, but there is another fault which is here, but this is more or less horizontal. So this is a typical deformation which we came across. There is another picture of that where you can see the inclination over here. Okay, and then there is some minor folding over here. Similarly over here, if you see this contact, then there is a folding here. So there is a fault which runs over here. So if you have this understanding of your primary and secondary structures, you will be able to fix up the things. Okay. Now this is the proper view of that trench which we excavated in Kutch. This paper is already published. We can share that paper on forum so you can go through. Okay. Now the primary goal here is that based on the physical properties, you can easily trace the layers. Okay. So this is one layer, the lighter color or yellowish, whitish yellow layer, which is sitting here, and you can see that these are all chopped along this line. Okay. There is another one which is sitting here, and the same one goes like this. Okay. So that's how one can make the interpretations. Okay, and this is the top, and then you are having this has been covered by this unit. Okay, and you can see here a clear cut inclination of the gravelly units. Okay. So these are all floodplain deposits, okay, which are deformed and displaced along a fault plane. So this is your fault line, okay, or the fault plane. Sorry, okay. This is your fault along which you have the deformation. So these are the same layers. Okay, you can just put here. This is the same layer here, and then you have this one is the same unit. So these are the arrows which shows, because there is a deformation here also, there is some sort of unbending which we see, and this line here which has displaced this units. Okay. So this you can have black and white also, that shows very clear cut deformation, as I was showing here, this one, and then second one is over here. Close up of that. Now you can have a very clear understanding. This sedimentary sequence, initially they were deposited in a horizontal fashion. Okay. So that they were deformed and displaced along this line. Close up of the southern side. This is the northern portion over here. This the next slide is there, and then next one is this one. Okay. So you can clearly make out the difference, okay, of the layers. So even you can have now one more fault which is running here, another one, and you see the tip of the fall is having all folding. Okay. So you have this unit, if you see, then it has been tracked like this. Okay. Now coming to the secondary structures, those were the secondary structures which we were looking at. Okay. So secondary structures, basically we try to see that the thumb rule, as I told, is your horizontal deposition and then subjected to deformation. So in terms of the metamorphic rocks, we see the foliations and all that, and in terms of the sedimentary rocks or the sedimentary successions, we will see folding and fracturing or the displacement, that what we call fault. Okay. Now coming to this section here, this is from the tidal deposits, and we see a very clear contact, okay, between this side and this side. Okay. But in this section, you have two types of, we can say, the contacts. Okay. Two type of contacts. One is this is what we have seen is the channel contact here in the previous slides also. This is also a channel. And then we have horizontal deposited material. But if you carefully see this one here, then there is some thing which is not very much like aligned with the what we were talking about, the primary structures. Okay. So if you carefully see this line over here, which goes up to this here, so you have layers which are displaced here. So along this line, if you see, and then this one here, you see a clear-cut displacement. And similarly, you can see here also. And major contact, which you can figure it out, is this one, okay, which runs over here. Now, this is related to your deformation. So you have in this section which has been shown here both primary as well as sedimentary contacts. Okay. And then we have here also, okay, this one also is your contact. Okay. So one can have, with this understanding, one can differentiate between the primary and the secondary structures. And the contact structures, as I told, that they are related with the unconformities, the period of non-deposition, and then also the intrusions which have occurred in the past. Okay. And those intrusions could be along the fault contacts also. Okay. And then we also talk about the shear zones. Okay. So unconformities, basically we say that it is one of the most common geological feature found in rocks or in the sediment successions. Okay. It is different than all other geological structures, namely the fold, joints and faults, basically the discontinuities. Okay. And unconformities are resulted due to tectonic activity also, because it can result into the areas are uplifted or subsided. Okay, then you will have sudden change in the environment that can result into an unconformity. Or you have the period of non-deposition. Okay. So this type of unconformities will be very sharp, and you will see a sudden change in the sedimentation pattern, or the depositional environment is completely changed. Okay, because you are having uplift or subsidence of the land. So now this type of unconformities are related to your non-deposition period or the phases, okay, that you can differentiate. But as I told, and the trench which I was showing, this is all the same area. Such unconformities are again related to your the next phase of deposition, where there is no deformation here. Okay, so next phase of deposition, but there is no deformation in this part. Okay, but the following the basal portion of the trench is clearly showing. So you have a horizontal deposition over here. You can see this is completely horizontal, and there is a contact, sharp contact between this. But the basal portion is having, you have an incline layers, so sedimentary layers. Okay, and over here you see a sort of a deformation also. So this are related to your secondary features or secondary structures related to deformation. Another example where you have a bedrock, even the sedimentary rocks are older here, and then this you are having quaternary deposits. This is again from the Kutch, and you see a sort of a clear deformation of the bedrock as well as your sedimentary successions. Okay. Typical folding. So intrusive contacts, usually we call that the contact structures. Okay, which has been seen here. That is like a very old feature which continued to get the ongoing deformation during the collision zone and all that. This is from the Indus Valley, intrusion of granite sheet like features you are having, and then you are having the gabbroic rocks here. Okay. Even on the smaller scale, you will come across such type of intrusions. That is, this is a dike, typical dike. Okay. Now you can have a wider dikes also, large dimension dikes, and that should not be considered as in fault contacts. Okay. So one has to understand that what is the process behind this. So fault contacts, a contact which developed due to slippage, or you can say the displacement of the rock blocks with respect to one another. One of the best example on surface you can see, and this is one of the dangerous fault system on this globe, that is San Andreas fault system. And you have contacts like this. Okay, these are again fault. Okay, and there is some sort of a deformation you can see over here. Okay, again another example. This is completely like non-deformation, no deformation has been seen, but here you see a clear cut deformation and displacement along the fault. Okay. Folding again is an related to your secondary deformational structures. And then you have some what we call is the secondary features. Of course, they will show deformation and they will show displacement, but they are not seismogenic. Okay, and that is because of the extension which you will see on the top of, or on this, the top surface of the mega folds. Okay, and that is what we call extensional cracks. Okay, and then you will also see a sort of a sharing along the limbs. Okay, so this I am showing because you have you will come across this type of uh, shear joints and tensional joints in Himalayas, because we have mega folding which is going on in that region. Okay. So we will stop here with this columnar joints. This again and non-tectonic features not related to your ongoing deformation, but it is related to your cooling pattern of the basalt, which are the magma which has been poured on the surface. Okay, and the lava flow. Okay, and then we have joints like this on the surface. You will come across in the folded stratas. Okay, and this part we have already seen that if you are having the deformation, how it looks like. Okay, the close up of that is this one. This is the part of this portion here, which shows a very clear micro faulting. Okay, and this is related to your deformation, and the major fault plane is this one over here. Okay. So these contacts are very sharp and very prominent. Okay. Another one here, you can see the deformation of this tidal deposits. Okay, along this line over here, it shows very clear cut deformation, and this portion has moved like this. Okay, and then in between you have the layers which have not experienced any deformation. Okay. So I'll stop here and we'll continue with this lecture with more details as we enter into the field techniques and all that. Okay. Till then, thank you so much. Namaskar.